And we're back. I am very refreshed. I've got a cup of tea, some oolong. Hopefully that'll help my throat a little bit. Let's get back. Oh, I'm in the wrong chapter here. Let's get back to either. Here we are. So I did, in fact, go refresh my memory on either. I've never used it in anger because I'm writing Haskell kind of as a hobby. And you might know that handling errors is a real pain in the butt. So if you're writing error handling code, it's always kind of painful. That's the reality. And so why would I want to do that to myself? Let me hop on the live stream. Oh, there's already someone watching. Well, probably me, actually. People will come in or they won't. I'm not too worried about it. Let me fix this. Got some of these various images working. All right. So what are we doing? Try to eventually write a solution that uses folder, even if earlier versions don't use folder. And what they want me to implement is that. Now I see there's an apostrophe there, so that probably means yep. And although they didn't say it, we need to import this probably. Right, let's make sure that still loads. It does. All right. So what do we have? We have a list of ethers, and we want a list of lefts, or in this case, A's. That seems very straightforward, but it's a list. So if we wanted to implement this from scratch by doing explicit recursion, we could do that. But I think we can. I think we are good enough with folder that we can just use it. So again, yikes. Start there. It's going to be a list, and we'll leave it point free for now. And so that means that X should be of type either AB, and ACK should be of type list of A's. So we can actually I'm going to do case analysis. Case X of. Otherwise, I think that's it. Is there a reason that wouldn't work? Oh, haha. I'm so used to the Data.Either course that did that. Couldn't match expected type A with actual type either AB. X is in either AB. Item is an A. That all makes sense. Oh. Yes. literally concatenated the wrong thing. And this, by the way, this is a good example of why I like using descriptive names. If I'd been paying attention to that, I would have caught it. What did I just do? I just messed everything up. Okay, do I have an example here? I don't have an example here. I'm going to trust that if it type checks, it works. Okay, we're going to do rights next, which is exactly the same, just with a different case analysis. Except I have to rename it. Sorry. I need a good example for either that I can type in here to test with, but oh no, the type is different here. Right. See, I was being lazy. Okay. Next, this one looks a little more interesting. Partition ethers. We have a question in the chat. Why do we use Haskell? Asks Himanshu Sharma, QI4EK. Excellent question. I am using it for fun. I don't use it in work. I'm using it very specifically just because it's so different from what I do in my day job. It has applicability. I think it sharpens your functional thinking in some cases. I've certainly changed the way I do things from using it for a little while. But you know, if you look overall at the overall popularity of the language, certainly it's not zero. There are certain companies that live and die by it, particularly in the finance sector. But, you know, lots of people don't. I'm using it because I like the concision, and I like it. Once I got over it, I like how it strips away a lot of the chaff in programming. You're really getting down to kind of like the bare essentials, which, you know, this is why we don't see a lot of end user Haskell programs, right? Why? Well, because user interaction is all about weird things that people want to do. You know, people are like, oh, Haskell is pure. It doesn't handle side effects. Good programs are all side effects. That's the truth. I'm going to step on my soapbox. I've talked about this in other videos. Pure, in the context of Haskell, is not a complement, right? Pure is meant to be this kind of mathematical description of something that doesn't have side effects. It's not positive. It's not negative. It's meant to be a dispassionate statement. What happens is people approach the language and they hear, well, Haskell's pure. And they get very excited about it because pure is a word that, in English at least, has positive connotations. And those positive connotations infect how certain people think about the language. And, you know, that's a category error. All right. Partition either. Where was I before ranting? Partition either. We're going to get a list of ethers. And we want a list of A's and a list of B's. This feels trivial. I think I have to have the... All right. This is like... kind of like the both of these cases merged. But our accumulator, we need to destructure. to lefts and rights. I think I'm allowed to do that. Left item, we're going to return that. Now if it's a right item, can I reuse? These are different types. Can I reuse that binding? I'm going to try and reuse it. We'll see. We'll see if it allows me to. It might not. I don't know if it's going to shadow it or if it's going to complain. Right? Let's see if that... Something's wrong. No, it needs to be a tuple of those. Okay, and that's partition either. It's very funny because I went back and read all of the either chapter thinking that these exercises were going to depend on knowing what an either is, and these do not. These are not great either exercises. It might be that we're going to get to them after this. But you could do these exercises knowing nothing other than basic types. And you need to know that either is a left and a right. That's the only thing you need. Either maybe. So this is going to take a function from B to C. And if we have a right value, we get a maybe. And if we have a left value, we're going to return nothing because we still have a maybe. We have a maybe either way. This is one of the things that is... I complain a lot about terminology. I know. I'm sorry. Some of the type level value, some of the constructors in Haskell, I just don't love. So let's take a look. I'm gonna rant. Right? So let's look at the maybe type. Okay? We've got a maybe an A, and it's either nothing or it's just an A. I hate every word in that definition except nothing. Nothing is okay. If you don't have anything, you've got nothing. That's okay. I hate that this is called maybe. It's not a maybe, it's an optional. Optional is such a much better word for that than maybe. And if you have something justify, it's just the word tea leaves. I hate that. I think some would be better. I think Data.61 does full versus empty. I don't love that. I think some would be what I would do. I would call this data optional A, nothing, or some A. That would be my naming. And with either I have a slightly different problem. Let's look at either. Okay. Let's see if I can get through this sentence without talking about cosplaying as a mathematician. There's always this drive in Haskell to go like maximal abstraction, right? Like, God forbid our types actually talk about what we want to use them for. What do we use either for? We use either for it's kind of like maybe, right, conceptually, but it's more specific. Either we have an actual value, some B, it succeeded, the operation succeeded, and we returned a value, or we have an error and we're going to pass back some information, some metadata about that error. That is what people use either for 120% of the time. No one in the entire history of Haskell has ever, under any circumstances, even if held at gunpoint, used an either for anything else. So why are the types called, why are the constructors called left and right? Like, someone was like, well, we don't know what these might be used for. We need to just call them left and right. And this is maximally abstract. Maybe we could just call them X and Y. Like, I hate it. I hate left. I hate right. This should be like either error, success. Error A or success B. That's what I would do. And, I don't know. I'm sure there's someone I'm making angry, and I'm probably wrong in some way, and someone's going to say, well, I know in this lens library we use either for some completely different thing, so I'm glad that it's left and right. I don't believe you. I think you're making it up. Should be error. Anyway, back, stepping down off the soapbox. Either maybe. Is that going to be a highlight reel? That might be on the highlight reel, I think. Okay, so we've got a function. And we have our either. We can do this without the function first, because if we have a left, and we don't even care what the left is, then we're going to return nothing. If we have a right, yeah, I'm gonna live my dream. If we have a right, then we're gonna do just that. That works, or type checks at least. All right. This is a general catamorphism for either values. Okay. We got lots of functions here. Take a sip of my tea while I contemplate this. Almost looks like composition, doesn't it? No, it doesn't. I'm wrong. So regardless of whether we have a left or a right, we're going to be able to transform it into the value on the right. All right. There's another one where, like, I feel like if this was concrete, it would actually be harder. Ha ha ha. You can't stop me. You can't stop me from calling left and right error or success. We can do this with pattern matching, actually. Always be pattern matching. Tell me true. Tell me true. Isn't that, assuming I did it right, isn't that so much better than that? Like, really? Really? That's this right here. This is standard Haskell. If this is in the standard library, I bet if we went to Google right now, like, that would be the implementation. I can't, my eyes don't absorb it. Last exercise in the either section. Same as before. Oh, so I can just copy the header and remember to change the name. Same as before, but use the either function you just wrote. Okay. We've got our function. We have our either. So to call either, we need this. Like, does this left case even need to be handled? Can I just pass ID? Maybe. So we pass ID if to be used if it's an error. No, we want something that's going to return nothing if it's an error, don't we? So this isn't even going to type check. Yeah. Expected B to maybe C. The second argument. Yeah, I feel like I'm not seeing what they wanted me to do here. Well, let's handle the failure case first, right? Like, I think that's true. Can I do that? Okay. H1 A to C. I mean, I feel like it doesn't matter what we pass here. Still doesn't like that. Couldn't match type A with C. Uh-oh, we're in the world where it's renaming things. That's not great. I feel like I'm rat holing on this. There's some simple explanation here that I'm not seeing. So I'm going to come back to this one. Unfolds. Do I really want to look at unfolds? I don't think I want to look at unfolds. All right, we got a real implementation here. Let me save these for later. Finally, something other than a list. That uses unfold. I don't want to do unfold. We're at the end of the chapter if I'm skipping unfold. The next chapter is all about building projects, and this is chapter 13. Let me bring up the book. This is a chapter that we should skip. I should do it, but we should skip because I believe that best Haskell practices have changed a lot since this book was written. I think this book is all about stack, if I recall correctly, which you can still use, but it's, you know, it's changed a lot since then. And then I think they also do a bunch of stuff about testing, and I suspect that that has changed as well. So the chapter I actually want to get to is functor, which I suspect is the next one after this. Let's take a look. Building a hangman project. Chapter on testing. Interesting stuff, but I don't think it makes for compelling YouTube. So, let's see. I think I should do it. I don't think necessarily I should do it here. And then we get to monoids. And again, I think I'm going to skip monoid and go straight to functor, because I understand monoids. I understand functors too, but functors lead to more interesting puzzles. Okay, well, I think I'm going to call it here. It's been a good morning. Thank you for joining me with my my terrible cold and my Barry White voice. And you've been watching Tea Leaves Programming. We're programming like it's 1979. Thanks for watching.